welcome to GeoZone Geoservices Geotechnical channel. Maybe I should call it GeoZone Geoservices TV. So, Gerald Davey here from GeoZone. So you may think that a geotechnical investigation is an unexpected expense, but I think intuitively you know that a house has to be founded on decent material. The foundations have to be taken down to, as the old biblical story goes, down to rock. Build your house on the rock, not on the shifting sand. So that's very much ingrained in our culture, irrespective of whether you believe the biblical story or not, or you know the biblical story. I think everybody fundamentally understands that a house or any building needs to be founded on decent material, because if it's too soft, it's going to settle and that's going to cause damage to the property. And of course, nowadays, insurance companies are actually pretty reluctant to pay out for settlements. So it would make sense to do the job properly at the outset rather than having to argue with insurance companies who probably are going to say no, and then you're in an underpinning exercise or trying to put in piles to try and support your foundation. And I promise you, I've been in this game for a number of years and I've seen some terrible, terrible things. So let's spend a little bit of money on trying to understand the geotechnical conditions that prevail beneath your site. So we do a lot of these kinds of investigations, and I think we can give you some good answers. So I often made the point, and in fact I wrote a blog post about this some years ago, that people spend more money on their Italian tiles than they do on the geotechnical investigation. And let me assure you, those nice hard porcelain ceramics are the first things to start cracking when there's subsidence, or the other topic I'm going to talk about, soil heave. Okay, so intuitively we know that foundations have to be taken down to a decent horizon, wherever that happens to be, or otherwise, if that's impossible, then we have to take another approach. But I'm not going to get into that here. I'm just talking about the reasons why you need a geotechnical investigation. It's all about risk management. The other thing that can affect a building other than soft soils, and no one really pays much attention to this, it's not quite so intuitive. This is an American story, but I know the rest of the world also has similar issues. I studied in Britain, and that's also one of their issues, and certainly South Africa suffers from the same issue, and that's expansive soils. So just going back to the American example, heaving soils, expansive soils cause more damage than hurricanes, earthquakes, and tornadoes combined. Okay, it doesn't lead to loss of life, but in terms of damage to property, soil heave is the #1 culprit in terms of damage to structures. Okay, so we need to pay attention to this. So essentially what happens is clays have a propensity to take up moisture in the wet season and lose it in the dry season. And so clay is a basket term for a whole bunch of different minerals, things like vermiculite, illites, smectites, montmorillonites. And so all these different clays have the capacity to absorb water, and some have a greater capacity than others. Things like montmorillonites can be incredibly expansive. So if your house or structure is founded upon an expansive clay, it will take up that moisture in the wet season and lose it in the dry, and that leads to soil heave. So the National Home Builders Registration Council, which I'm sure you're going to bump into in your development adventures and your development travels, the NHBRC, have spelled out what the limits are in terms of soil heave. So anything less than 7.5 millimeters. So you think about what 7.5 millimeters is, it's a tiny amount. So if the soil heave, that seasonal fluctuation between the wet and dry season, if that soil heave is less than 7.5 millimeters, you don't have to do anything in terms of an intervention in your foundations. You can just bound your structure on normal strip footings, but between 7.5 and 15 millimeters, you have to start thinking about reinforcing your foundations and putting articulation joints in the masonry and probably some brick force into the brickwork. Anything above 15 millimeters, you are in the realms of a raft foundation, a stiffened raft. So a stiffened raft is essentially a solid, stiff foundation, and as the soils heave and this thing rocks, it's like a raft on the ocean. So you can ride out those waves of expansive, and as the soil expands and contracts, this thing is a stiffened raft and the house sits on top of it. It doesn't really matter what happens. This thing will remain stable and keep your house intact. So those are not huge amounts. Certainly that 7.5 millimeters and less, that's not a lot of soil heave. But anything above that, you start having issues. And I know back in the 1960s in the Free State goldfields, where a lot of work was done around Welkom, there's some really, really shocking effects of soil heave. Those houses that were built there were absolutely destroyed thanks to the heaving soils. So we need to be very, very careful of that. And then the third issue, and this isn't so prevalent around the rest of the country, but places like Durban, for instance, and going up the north coast on those ancient dune sands, and also going down the coast, the Berea red sand, there's plenty of that stuff around, and those are old fossilized sand dunes, essentially. So they're wind blown, and they have a voided structure. And if you load them and at the same time wet them up, from rain or badly managed stormwater or septic tanks, those things can also collapse. And when there's collapse potential, down goes your foundation 10-20 millimeters, and of course damage to your house. Okay, so we need to be careful of these things. So what we do in a geotechnical investigation, we go to site and we'll dig some holes. Either we can dig them with a TLB if it's a big site, or we can come in with a hand auger if it's just for a house, and go down to 3 meters with the auger, and we'll profile the soil horizons. And that also allows us to take a sample, an indicator sample, which we'll put in the laboratory, and they'll run an indicator test. We will also carry out dynamic cone penetrometer tests, so that drives a cone down to depth, and we can assess the stiffness, the consistency of the soils, and that'll tell us where a good bounding horizon lies. The laboratory should give us a turnaround in a week, maybe 10 days in terms of the indicator test, and that will tell us the expansiveness of the soil and the liquid limit, and of course how much clay is in the soil and sand and gravel and anything else. And from that we can make an assessment as to the heave potential of the soil that underlies your foundation. Okay, so calculating the heave of a soil, we get a result back from the laboratory, and it tells us whether it's low expansive or medium expansive or highly expansive. And that's only one aspect of it. So the other aspect of it is how thick is that clay. So we've got to calculate the cumulative heave. So for instance, 0.5 meter of highly expansive soil under your strip footing, if you calculate the cumulative heave, you'll come up with a figure, and you might find, in spite of the fact that it's a highly expansive clay beneath your footing, if there's only 0.5 meter of it and then you hit rock, well, you don't have much to worry about. But you might have 3 meters of low expansive soil, and if you calculate the cumulative heave over that, you might find that you actually have to do some kind of intervention in terms of reinforcing your foundations, or putting in a stiffened raft foundation, or whatever it happens to be. So that's the reason why we auger down, so we can see what the soil profile is like, where the rock is, where the water table is, because obviously any clay below a water table is saturated, and so it's already expanded. And the other thing is we auger down to get a sample, which, as we talked about already, goes into the laboratory. Okay, so we do the augers and we do the DCP tests. We get the foundation indicator test result back, and then we can provide you with a report as to the expected heave and the settlement, and what kind of foundation you will require. And then finally, and this is just ticking the statutory boxes, the NHBRC will ask me to sign an EF003 form. So we are registered with the NHBRC, so we'll barcode that and sign it, tell you what the site classification is, whether it's an H, H1, H2, H3, or whether it's collapsible, C1, C2, C3, or settlement, S1, S2, S3, and or maybe a combination. And that will go in with your submission and hopefully tick all the boxes from a geotechnical point of view. So I often use the example, well, you don't wear a seatbelt to keep the police happy and not get a fine. You put your seatbelt on so that if you should have an accident, you will be restrained and hopefully not be injured in the accident. And similarly, so you carry out a geotechnical investigation, not so much as to tick the statutory boxes, but to make sure that your house isn't going to settle or be subjected to soil heave or soil collapse or any of those other untoward things that you wouldn't want to have, because I promise you, it's very difficult to fix these things afterwards. We've tried to underpin foundations in our time, and you can meet with success if you get it right, but of course you might have to break through the concrete floor, you might have to break through the slab, you have to auger down and put in piles adjacent to the footings, and then put in some cantilevers from the corbel, the top of the pile below the footing, and it can become a very expensive exercise. Some years ago I think they were charging 10,000 Rand a pile. And if you're having to install a pile every 2.5 meters, that becomes an expensive exercise. So we don't want to go there. So let's just spend a little bit of money up front, work out what needs to be done. We'll make recommendations as to what foundations are required and submit all the necessary paperwork, and then everybody's happy. The reason why the NHBRC put these things in place is because there was a lot, I guess, what one would call cowboy construction going on, and no one is paying attention to the geotechnical component of things. Let's just dig the strip footings, throw in some concrete, and then build your structure off there, your brickwork. And 3 or 4 or 5 years later, the house is suffering undue damage due to settlement or soil heave. Okay, so I think I made my case. So we look forward to being of assistance in terms of the geotechnical aspect of the site. And of course, when we're there, we'll look at all the other things there too. There might be a slope that might need attention. Slope stability is always an issue. Where the water is, what's happening. And another thing that we do, and you might have to pay attention to this, if there's no waterborne sewage, no municipal connections there, then you will have to do percolation tests and a septic tank design. So I'll talk about that in another video, but I've already, I think, taken up too much of your time now. So if you want to watch a video about the importance of percolation tests and what the requirements are, and how we go about that, I'll put the link in the description below. Okay, so I think it's been quite enlightening, and I'm looking forward to being of assistance in your project. Okay, so I will maybe see you on site, I might see you in a meeting, or maybe you just want to learn a little bit about geotechnics, and if that's the case, just follow our channel here. Okay, so I'm out of here. So until then, you take care. Cheers, bye.